Hello guys, welcome back to my channel. So today we are going to start another very important course which is related to the MATLAB. So what is basically the MATLAB? MATLAB is the abbreviation of Matrix Laboratory, which is a numerical computation package by MathWorks. So basically there are plenty of uses, plenty of applications of MATLAB which are currently in use. So the basics of the MATLAB will be covered in this course. Similarly, we are going to discuss different applications of the MATLAB in signal processing, image processing and variety of the fields before diving into the Python and different packages of Python for the same use. Okay, so it is important to go through all the applications in the MATLAB, and then after it we will go to the Python packages just like NumPy, SciPy, Pandas, and see the similarities between the MATLAB and NumPy and other packages. Okay, so let's get started. So in this is the MATLAB 2013B environment. Here you can see different options. Here we have different toolboxes here, just like in the form of ribbons like file, variable, code, Simulink, environment, resources. This is a ribbon. Similarly, here we have different options here, just like new script. What is a script? We will talk about it in our later videos. Similarly, for new file, we can see here there are basically script files, function, example, classes, and so on. To open the currently available file, we can basically go here and open it from this option. Similarly, other options are also available like import data, save workspace, and so on. Simulink is also a very important library or the very important package which is basically used for simulating the different engineering systems in the form of S domain. Okay, so what is the S domain? What are the uses of the Simulink? All will be covered in this course here with us. Okay, so in the environment here, this is the current path here, and we can see that the current path is basically listed here. We can also change the current path from here. Okay, similarly here we have the current folder, and in the current path, what are the available files in the current folder we have. So these are the available files here. Similarly here we have this workspace. So what is the workspace? So whenever we will initialize or declare some variable, that will be placed inside this workspace or stored here. And similarly, this is the command history here. So the command history basically shows you all the commands which were previously executed by the MATLAB command. Okay, after it we are here for the command window. So the command window is the basic or the prime entity in our MATLAB environment. So what is the command window? When you execute some command, so output will be seen here. Okay, so the output of all the files or the commands will be shown here. So let's start it with some variable or some operations here. So let's say you want to add two numbers here. So just writing 3 plus 4 and then press enter, you will see that 7. Okay, here ans is basically the default variable which is used to store the variables or quantities which were never assigned to any variable. Okay, so when this is executed here, you can see that in workspace the variable ans has been created, and double clicking over it, you will see that the data type which is the double data type, and similarly you will also see the location here. Okay, you basically have to remember that all the things whatever we will do in the MATLAB will be saved and will be executed in the form of the matrices. That's why this is called the matrix laboratory. Okay, similarly if you want to divide two numbers like 60 divided by 5, what will happen? The answer will be replaced with this number now. Okay, so that is all about it. Similarly, if you want to assign it to some other variable, just let me call it a. So let me call a equal to 90, and writing it, you will see that here variable a is created here, and similarly the value of a is also been shown here. Okay, if you want to create the variable and don't want to show it here as well, what would you do? You will write, let's say b equal to 8, and after writing it, what would you do? You will just write or put the semicolon at the end of the command here. So just writing here, you will see that it is not like the previous ones where when I executed the command variable and its value has been shown, but here it is not shown because the availability of this semicolon here. Okay, so similarly you can also see that the variable b has also been created in the memory. Okay, so that is all about the single variable. Similarly, as the environment here is the matrix based environment, so you can also write different matrices, different vectors here. So let us have a single vector here. So c equal to, after it what you will have to do, you will have to put two square brackets here, and then you have to write the values inside these brackets. So what would happen, so let me write the multiples of 3. So 3 comma 6 comma 9 comma 12. Okay, so this is now the variable c, and just by executing it you will see that the variable c has been created and the values are written here. Okay, so these are 3 6 9 12, the values are here. Similarly, if you want to go to the previous commands here, so just like the Windows terminal, what you can do, you can basically press the up arrow here and you will get the commands which you have previously executed. So you can see here, and similarly here you can also press the down arrow here in order to see the next commands. Okay, so here you can see that after putting, you will also use it. Okay, so in order to show the different elements here, what you can do, you can write c and after it you can put basically the brackets here, and let me write 1. So what will happen, the first element of my vector will be displayed here. Okay, so there is a very clear difference between the MATLAB and other programming languages just like Python, which we have previously covered, and also the C++, where all the indices starts from 0. Similarly, in order to access the indices, what you have to do, you basically put the square brackets here. The commands are slightly different because you have to write the round brackets here, and when you will write 0 here, it will give you the error because the indices here starts from 1, while in other languages it starts from 0. Okay, so when you will write 1, it will basically show you the first element. Similarly, if you write the -1, so it is also not the legit command here. So -1 is also unknown, which was basically known in the Python languages. So similarly, if you want to show the second element here, so you will write here 2. Okay, so I think it's enough for today, in which we have discussed the basics of the MATLAB and also basics of some vectorized variables, and after it, in our next video, we will talk about different matrix calculation methods. In our next video, we will talk about the basic functionalities of the matrices and how linear algebra and matrices can be used in different fields of the engineering and sciences, in image processing, in signal processing, and we will basically go to the advanced level in our course. Welcome back. So last time we discussed some very essential commands and options in the MATLAB environment. So today we are going to discuss some more of the commands and some of the tips and tricks which you can use in your programming assignments. Okay, so let us have again some commands here. So in our first command, let us have a variable like a equal to 10, b equal to 7. Okay, and these are the variables which are again saved in my workspace. In order to see the values here, what I can do, I can just type them here, and after pressing enter, these will appear here. Okay, so this is one of the other method of displaying the value of any variable. Similarly, if I run or write b here, what it will do, it will basically print the value of b here. Similarly, I recently told you guys that ans is another variable which is by default variable which is used to store the values of any command which were not previously assigned to any other variable. So writing ans here, what it will do, as no value has been previously assigned to a and s, so therefore it is not showing me any value here. Okay, similarly, in order to see the type of the variables which I have assigned here, what I can do, I have the function here which is called class. Okay, so after class and then the brackets here, and after brackets what I can do, I can basically put the variable here in order to check the data type of the data which is basically the a has. Okay, so after writing it and pressing enter here, it will basically show me double because a is the double data type. Okay, similarly, if I have another variable like c equal to, let me put here some value here, and that is, let me call it MATLAB. Okay, so this is the MATLAB. In order to show it, I can write again here C. Okay, so again writing class here, and in class again bracket open C and then bracket close. What it will show me, it will show me that it is the character data type. Okay, so in similar manner, it will show me the data types of all the variables which I will assign them. Okay, so this is all about the variables. So what if I want to clear this command window? What I will do, there is a command here that is called the clc. So writing clc here, what it will do, just writing clc here and pressing enter here, it will basically clear the command window here. Okay, so what if I want to clear the variables here, what I will do, there is another command and that is called the clear. By writing clear here, what it will do, it will clear this workspace here. So okay, so after pressing enter, you will see that no variable is now available in this workspace. Similarly, we are going to discuss some other operations which are related to the vectors or matrices. So in our next lecture, we will talk about the matrices. In today's lecture, let us talk about the vectors. So suppose I have a vector like this one, 1 2 5 6. Okay, so this is a vector here, and this is also called the one-dimensional array here. Similarly, in order to find the transpose of it, what I can do, I can write a, and over it I can write this inverted comma, and pressing enter here, I will see that this was basically the row vector, which is now converted into the column vector. Okay, similarly, this is the transpose here. In order to find different elements here, I have recently told you that I can write this here. So let's suppose if I want to find the fourth element here, it will show me that this is 6. What if I want to find the first three elements here? What I will do, so there is this colon here. What it will do, if I want to find out the values of first to third entity here, what I will do, I will write 1 and this colon, and at the end of it the third element. So what it will do, it will give me the first three elements. Okay, so that is the slicing operation which is carried out by this slicing operator here. Similarly, what if I want to find out the solutions of some equation? So let us have the equation here. So let me go to the here. So let us have the equation here, and that is the 5x plus 10. We can very easily see that in writing or solving it manually, what I will get the roots of this equation, and that is the -2. So value of x equal to -2 will satisfy this equation. How to solve this equation by using the MATLAB, this is the topic of this item here. So again, we can very easily see that we have two coefficients here. This 5 is the coefficient of my x term, while 10 is the bias or the constant term here. So in order to write the coefficients here, what I can do, I can very easily see that the coefficients here are basically 5 and 10. So let us find out the solution of this problem by using the MATLAB. So now again, going to the MATLAB terminal here. So let me have d, which is basically 5 and then comma 10. You can write the comma here, or you can also put space here as well. Both of them will give you the same meaning. Okay, so writing d is equal to 510 and then assigning it to the d, and after it what I can do, there is a command here that is called the roots. So roots here and then d, putting the value of it, what I will get here -2, which was the same answer which we have seen previously. Okay, so that is about the solution of the first order homogeneous or non-homogeneous equations. Okay, so through this you can solve as many questions as possible. So if you have more than one equations here, how you can solve them, that is now the problem of the matrices, which we will see in our upcoming next video. Thank you so much. Practice over all the commands which I have shown you here, and after it don't forget to CLC clear, and after it, once you are done, just write exit here. So after exiting, what it would do, just pressing enter, and you will out of the MATLAB package. Welcome back. So today we are going to start a very important topic, and that is related to the matrices. Okay, so as I have told you earlier that the MATLAB package basically works on the basis of the matrices. It basically converts all the numbers into the matrices and then process them accordingly. Okay, so today we are going to start it with the procedure that how to convert any numbers or how to save any matrix in the MATLAB environment. Okay, so suppose we have a matrix A, and in which we are going to define a matrix which is of size 2 cross 2. Okay, so in order to construct a matrix, first of all you have to write these square brackets. Okay, and after it, what you have to do, what you have to do, first of all you have to write the first row, then the second row, and then the third row. Okay, then each of the row will be separated by using the semicolons. So first of all, let me have the first row. So in first row, let us have the first element 2, and the second element I have is the 3. So this is my first row. Similarly, in order to have the second row, what I have to do, when I will start the second row here, what I will do, I will just put the semicolon here, and after it, what I will do, I will write here the values which are in the second row. Okay, so once the values are assigned to the matrix, I can press enter, and after pressing enter, I can see that these are the values in which the first row consists of 2 3 and the second row is here 7 8. Okay, so that is the matrix A, which is also available in the workspace. And once I will try to see the workspace, here you can see that in the first 1 1 entry I have 2, in 1 2 entry I have 3, and so on. Okay, so these are the entries of a matrix. Similarly, the size of the matrix is also given here, and it is of data type double. Okay, in order to see the size of a matrix, what I can do here, I can also write the size command here, and after it, let me write the name here, and it will give me 2 cross 2. So the first 2 is for the rows and the second 2 is for the columns. Okay, so that is about the matrices. Similarly, you can also construct the 3 cross 3 matrices. So suppose I have B, which is the 3 cross 3 matrix. So let me have here 3 6 9 in the first row, similarly 2 4 6 in the second row, and in the third row I have, let me have 4 8 and 12. Okay, so these are the entries in the matrix of size 3 cross 3. And how to check the size of this matrix, I can check its size by this command. Okay, so in order to show the matrix B, what I can do here, I can just write the value B here, and it will show me all the values which are now available in my matrix B. So that is the procedure of defining or initializing any matrix in the MATLAB environment. Okay, despite or instead of all this, I have some built-in matrices which are available in the MATLAB environment. So the first very important matrix is basically the zeros matrix. So let me have Z, and Z is equal to the zeros. So the zeros is the built-in matrix in which inside of these brackets I can write the size of the matrix which I want to get. So if I will write here 2, it will give me a square matrix of size 2 cross 2. Okay, so if I don't want to get the square matrix, what I can do here, let us say I want a matrix which will have 2 rows and 1 column. So what I will do, I will write 2 comma 1, which means that I want a matrix of zeros which will have 2 rows and 1 column, and you can very easily see that it is like this matrix. Okay, similarly Z2 can also be written like zeros, and the entries here, let me have 2 rows and 3 columns. So 2 rows and 3 columns are here. Okay, so these are the entries for the zeros matrix. Similarly, another very important matrix is of ones, which is consist of all the ones. Okay, you will see the usabilities of the zeros and ones matrix in many applications, and you will see that the availability of these type of matrices is very handy, which will make most of your tasks very easy. So now let me have another matrix, and that is the 1. So let me have O, and for O's I will write 1s, and in this again the same procedure will be followed here. If I will write 2, it will be 2. If I will write, let me call it O1, and O1 is 2 cross 1, it will be same like 2 rows 1 column. Similarly O2, let me write it 3 rows 2 column, and so on. So this is the same matrix, which this all the procedures are the same which I have used for my previous zeros matrix. Okay, the third matrix, which is also of very much importance, is the identity matrix. How to define the identity matrix? So you know the identity matrix. Identity matrix is basically the matrix which has all the diagonal elements equal to 1 while the other elements will be 0. Okay, so that is basically the square matrix in which all the diagonal elements will be 1. Okay, so suppose I want the identity matrix, and let me call it capital I. So in order to construct the identity matrix, the MATLAB has a built-in command which is called I. So in order to write it here, what I will do, I will only write the value here, and after writing it, it will give me the identity matrix. You can see that all the diagonal elements here are identity. Okay, basically you don't have to write the other element here, because the identity matrix is always the square matrix, and you don't have to mention both the dimensions of the matrix. So therefore giving only one dimension will be enough to construct the identity matrix. Okay, similarly if I want to construct a matrix of size, let me call it 5 by 5, it will give me this matrix. Okay, so that is the identity matrix. Similarly, despite the identity matrix, sometimes I also need a diagonal matrix in which I will have some elements, and why I want to put those elements in the diagonal of a matrix. So suppose I have the values which are V. So in V I have some values like 2, 4, 8 and 9. These are 4 elements, and I want to construct the matrix in which these 4 are basically the diagonal elements. I can also do this by constructing the identity matrix first and then assigning each value to the respective elements of the matrix, but it will be a very lengthy process. So instead of doing all this, MATLAB basically make it easier for you to just write the command diag and writing V here and just pressing enter. What it will do, it will just construct a matrix in which the diagonal elements will be 2, 4, 8, 9. So this is basically the diagonal matrix which I want. Similarly, if I have V2 and in V2 I have 2 elements which are 10 and let me call it 200. Okay, so this is V2, and in order to construct a matrix D1, and that is basically the diag, that is the command, and writing V2 here, it will give me this matrix. So that is a very handy matrix which you guys will use in many applications. Okay, similarly another very important type of matrix is the random matrix. So in order to construct a random matrix, what I have to write, I have to write rand, and writing 3 here, it will give me a square matrix of type 3 cross 3. That is the rand matrix which basically give you the random numbers from 0 to 1, and writing only one element will give you the square matrix. Similarly, if you want to construct a matrix of your own dimension, just like 2 rows and 4 columns here, and writing it will give you the same matrix here, which will basically give you the numbers from 0 to 1, and also any other matrices here as well. Okay, so this is the random matrix. Writing rand 3 4 will give you the matrix of size having 3 rows and 4 columns. Okay, so that is one of the very important functionality of the rand function. Similarly, now what if I want to construct a random matrix which is composed of numbers of the norm from the normal distribution? So in MATLAB, that is the rand n command, and writing the rand n command, what it will give me, it will give me the random numbers from the standard normal distribution, okay, which have the mean equal to 0 and standard deviation equal to 1. Similarly, for writing it to construct your own shape, it will also give me like this. Okay, so that is the random normal distribution. Similarly, if you want to get the numbers which are of type integer, what you will do, so this MATLAB has also another type of random number generator, that is the rand int. In order to construct it, what you will do, you will add rand int and then writing 3, it will give me this one. Okay, similarly, just for writing 1 3, what it will give me, it will give me like this one, and so on. Okay, similarly 3 rows 1 column. Okay, this one similarly writing it. So you will see that every time I will run it, it will give me the numbers from 0 to 1 in the combination which is given here. Okay, so that are the random integers, and I can also run them like this. Okay, basically this means 3 total numbers or the range of numbers. Similarly, let me try it as well, 20. So it will give me the numbers in the range of 0 to 20 and size of 3 1. So you can also see here that the size of it is again 3 cross 1, while the numbers are from 0 to 20 here. Okay, so running it again, you will see that the numbers are again from 0 to 20 and so on. Okay, so that is about the random integers which I can create from this one. So that's it for today, in which we have discussed the matrices and what are the different types of matrices which are available in the package, which we can use for our own benefits. I will see you with some more functionalities and more matrix operations in our upcoming video. Welcome back, guys. So we have seen different applications of MATLAB in plotting and numeric calculation as well. We have also seen the application MATLAB while we have to solve different number of equations. So we have seen a method which was basically on the basis of the finding the inverse of a fat matrix and multiplying it with the vector will give us the output vector matrix. Okay, so today we are going to find a method which is based on the equations, and we are going to find the solution of different equations as well. Okay, so let me go to this page and let me have some equations. So suppose the first equation we have is 4x square plus 2x plus 1, and we have to find the solution of it, and the solution of it will be the roots of this equation. Okay, so finding roots of this equation, basically there are 2 roots of this equation. Why do we have 2 roots? Because the order of this equation is 2, so therefore we have 2 roots, and in order to find the roots of it in MATLAB, what we have to do, first of all, we have to write the coefficients of this vector in the MATLAB format, and writing it like here we have 4, 2 and 1. These are the elements here, and after it we have to apply some functionality. Okay, similarly, if we have other type of equations as well, let me have 5x4. Okay, so in order to convert it into the MATLAB vector, what we have to do, we have to write here 1 0 0. This is the 4th coefficient, this is the 3rd, this is 2nd, this is the 1st, and this is the DC term. Okay, so these are basically the coefficients in it. We have 4 zeros while 1 coefficient with which the equation will be here. So here with x of 4 we have 5. So despite writing 1 here, what we can write here, we can write here 5. Okay, so after it we have to apply some function over it. Okay, so what are those functions? Let me go to the MATLAB command window and writing here my first function as a equal to, what was that? That was basically the 4 to 1, and this 4 to 1 is basically this equation 4x square plus 2x plus 1. Okay, so that is 4 comma 2 comma 1. Okay, so this is my vector here, and in order to find the solution of it, we have the function here, and that is the roots. Okay, so writing it here, it will give me the roots, and we can very easily see that in this equation the roots are basically complex. Okay, similarly if we have another equation, and that is x square plus 2x plus 1, that is a very well known equation. So let me write it here again. So another equation here is x square plus 2x plus 1 equal to 0. Let me write it here, and we can very easily see that the root of it will be minus 1 because two roots here, and these two roots will be here because this is now x plus 1 whole square equal to 0. Okay, so let me write the coefficients of it, and let me write those as c equal to 1 2 1. Okay, and then finding the roots of it, how would we find it? Let me go here again here. So it will be 1 2 1. Okay, and writing roots here as well, it will give me minus 1 minus 1. Okay, so that is it. Similarly, in order to find the roots of my equation b, which is here, okay, this was basically the equation b, and here we have to find the roots of this equation. How would we find it? So writing it now 5 0 0 0 0. Okay, so how many roots will I have? I will have 4 roots. Okay, so writing roots and b with it, I will see that the roots here are zeros, and it is also clear from this equation as well that the number of roots here are 4, and all of these are basically 0 because only the value of x equal to 0 will give me this equation equal to 0. Okay, so that is about the root equation, and we have seen the applications of it in finding the solution of the number. Okay, so this is another lecture which is related to the MATLAB. So today we are going to discuss another very important topic, and that is regarding the scripting of any programming in the MATLAB environment. Okay, so suppose we have some statements which we are going to write here in the command video, and those statements are basically interdependent or each other. And for writing each and every statement here in the command window, what we have to do, first of all, we have to define some variable like a equal to 10. Then after it we have to process it by using some other processing thing like c equal to a multiplied by 3 and so on. And after writing all those statements, what will happen if we want to run those again? What we have to do, we will go back to those statements and then run them again here. Okay, so it will be a very tedious task, and it is not a very professional way of writing any program. So in order to, let me clear it first. So in order to avoid these type of confusions, there is a platform or the file extension in the MATLAB, and that is called the script environment. Okay, so script files or the .m files in the MATLAB are the ways in which lengthy programs can be written and can be run over and over again. Okay, so suppose if you want to create a program, what you have to do here in the left corner, you have to click over the new script file. After clicking over it, you will see that another window will appear, and here this is the environment where you can write your own program. So suppose what we have to do, I am going to write a program which first of all initialize the variable a here, and after it will display the value it has. Okay, so what will be the value here? So displaying any value here, I will have to write the command here, and that is the disp. Okay, so in order to display anything, what I have to do, I have to write the variable or anything here inside the brackets. Okay, so after writing it, what we have to do, we have to save it. So let me save it with the name of first. Okay, so that is, and the by default extension of it is .m, and it will be saved in my path where I have stored all my variables, and that is the path of all the files here. Okay, so let me save it here, and after saving it, there is the button here, and that is the run button. Okay, so I can also press here F5 as well. So let me run it here by clicking over it, and to see the results, what I have to do, I have to get back to the command window, and here I will see that the results will be shown here. Okay, and that is the value of the A. So that is the scripting procedure in the MATLAB file. Okay, so in order to write the comments with my statements here, each and every one of these line is basically the statement here, and in order to write the comments here with each and every line here, what I have to do, there is a percentage sign, and it is used for the commenting here. So let me write the comment here, is that variable initialization, and this is the value display. Okay, so comments are the statements which are basically neglected by the environment, and these statements are not used by the programming environment for the running. Okay, so once I will run it again, what will happen, you will see that the same statement will be displayed here. Okay, in order to run it again, what I have to do, in the command window I can write first, and you will see that it will show me the values here. Okay, so in order to reinitialize all the values, or to display all the values, I have basically a very important thing here for you all. So what you have to do, first of all, you have to write the CLC and write clear here as well. So by writing all these things here, you have seen here that whenever I will write this first, it will be displayed after the commands which I have executed earlier on. Okay, so in order to display it in such a way that all the previous commands will be removed, all the variables are removed, and it will be started from the very beginning, what I have to do, I can write here the CLC and clear, and after clear I can also write the clear all. So that is the professional way of writing any program here, and I will see here that now let me save it, Control S, and I will see that now when I will press first, I will see that only 10 will be appeared here, and after writing it, I will see again that 10 will be appeared. Okay, so sorry, that is first. Okay, so that is a more professional way of programming. Okay, so now this is the displaying here. So suppose what if you want to get some input from a user and you have to display it. Okay, suppose you don't want to display this 10, but you want the user to display to enter an input, and you want to display it over here. What you will do, there is a method or function here, and that is the input function, and inside of it you have to write the statements that what you want the users to read. Okay, so suppose enter the value of A. Okay, and after running it, let me save it, and now when you will run it over here, what it will do, it will ask you to enter a value. So let me enter here 20. So what I have written there, when I will write this value, what it will do, it will display it. Okay, so that is the functionality of the input, and I can use it here as well. Okay, so in order to write some more programs here in this one script file in such a way that these will be divided into some chunks or some parts of the programs, in order to construct separate sections of the programs here, what I can do, I can basically write here 1 and 2. So writing two percentage signs, what I can do, I can write some other programs here as well, so which can also work separately in one script file. So giving it the name like second section. So let me have here another procedure, and it sees if a user which has entered some value is greater than 10 or not. Okay, so suppose if a user has entered a value a and I want to see that whether that value is greater than 10 or not, what I will do, there are some other statements in the MATLAB as well, which are also already available in the C, C++, Python as well. So these are called the conditional statements. So in conditional statements, I see that whether a value a satisfies some condition, then I have to perform some functionality over it. Otherwise, you can perform the other functionality over that variable. Okay, so suppose what I have to do, I can check that whether the value here entered is greater than 10. Okay, so if the value is greater than 10, what I have to do, I will display, let us say I want to display that the value is greater than 10. Okay, if it is not greater than 10 means else. So what it will do, it will display the value is less than 10. Okay, so after it, what you have to do here, in order to tell the package that now I am going to leave this if statement, so what you have to do, you have to write here this AND statement, and you will see that after writing this AND, this is now complete, and here you will see after it and running it here. So now let me run it. It will ask me to enter some value, and let me put 20, and it will first of all display it and then tell me that it is greater than 10. Okay, so let me run it again, and now again it will ask me to enter the value of a. So let me enter 5 here, and it will tell me the value is less than 10. So in this way I can run this overall program. But initially I have told you that this program can also be run in the form of sections, and I have divided it into the sections by using this statement here. So what I have to do in order to run this section which is above this line here, what I can do, there is a run section command here. When I will run it, what it will do, it will run all the statements which are above the line. So it is asking me to enter the value, and while I will enter it, it will just display it and not checking that whether that value is greater than 10 or not, because those conditional statements are written now below this line here. Okay, so this is the line. If I want to run this section here, what I will do, I will write this section here, and after running it, it will not ask me to enter any value, because that value has already been entered, and it will now check whether that value is greater than 10 or not. So as the value of 2 was less than 10, so it will display the value of 2 is less than 10. Okay, so that is the essence of the conditional statement, and you can use it for your own programming and for your own purposes as well. Okay, so that is all about the conditional statements. Similarly, what if you want to repeat some statements inside the MATLAB program? So repeat the functionality of some statements. So those are basically the loop statements. So in order to use the loop statements, what you have to do, so suppose you have, let me use another section here, and that is this one, and let me call it loop statement. Okay, so once you have entered some value, what you will do, you want to display all the values from 1 to that number here in this program. So for that I can use a loop, and that is the for loop. So for loop, what I have to do, what is the syntax of the for loop? Initially what you have to write, the for, and after it you have to initialize or declare some variable, and that is here, let me call it I. So run I equal to from 1 to the value a. Okay, so that what it will do, it will display all the values from 1 to a. What is the a? The a is basically the value which a user has inserted before. Okay, so what it will do after it, this, and it will now display a, and after it you also have to write this and as well. Okay, so let me run it now, the overall statement. So let me write here 10 or 11 here as well. So let me write 11 here. What it will do, first of all, in the first here, it will display the value of the a, then it will check whether the value is greater than 10 or not. So as the value of 11 is greater than 10, so it has displayed that the value is greater than 10. And my loop statement, what I have told it, that for I equal to 1 to a, this colon is used for 2. Okay, so if you want to display some value from some number to another number, what it will do, it will take this initial number, then the semicolon, sorry, the colon, and then this, the end number. And as I want to display it, I will do this one. Okay, similarly, what is the use of this colon here? So suppose if you want to have a value of b which should consist of all the values from 0 to 100 which are even numbers. Okay, so in order to write the values, so in order to write all the values from 0 to 100, what you can do, you can write 0 to 100. Okay, so after writing it, or let me call it from 0 to 10. So for the simplicity, let us write it a small number. So when you will put it like this, what it will do, it will write all the values from 0 to 10. Okay, so but if I want to get all the numbers which are even here, what I can do here, I can write here 0 to 10, while the step here is 2 digits away. Here you are getting first number, then the second number which is 1 number away, the third number which is 1 number away from the consecutive number, and so on. So these are all the consecutive numbers which are basically 1 number away from each other. So now if you want to create a number which are 2 numbers away from each other, you will have to write this one. By default, if you write this one, so here the numbers will be 1 figure away or 1 digit away from each other. So writing it here, what it will do, you can see that now these are 2 digits away, and you can see that these are all the even numbers. Similarly, if you want to make them 4 digits away, what you can do here, the 4 digits away numbers are basically these 3 which are 0, 4, 8 and so on. If you want to make them 200, what it will do, it will write all the numbers which are away from each other 4 digits. So 0, 4, 8, each and every consecutive number is 4 at the difference of 4 from each other. So writing like the greater number minus the smaller number here. So what I will get, 80 minus 76 is 4, 76 minus 72 is 4 as well. So that is the essence of this colon operator. Similarly, what if you want to generate the numbers which are in the reverse order from 10 to 0? So what you will do, so let me write C here, and the initial number here is 10, and writing colon here and then the 0 here, what it will give me, as here it will not work, because now you can see that from 10 to 0 it will again create the numbers which will be basically 1 digit away from each other. So in order to go from the higher to the lower number, what you have to do, you have to write here -1. So writing it here, you will see that these would be in the reverse order. Similarly, if you want to make them 2 digit away, this one, and if you want to make them 3 digit away, and this one as well. So that is the procedure in which this colon operator works. Okay, so that is all about the colon operator, the loop statements here, and so on. Okay, so that is all about the loop statement. Similarly, what if you want to have some conditions in the loop? So in that case, this loop statement you can use here is basically the while loop. Okay, so using while loop, using while loop, you can write here the while, and after inside these brackets here you can write some condition. So suppose you have some value here, and the value here is of b, and initially the b value of b is, let me call it 5. So unless and until the value of b is less than or equal to 10, okay, what you have to do, you have to display running, and after it you have to make it increased by 1, and after it end it. Okay, so let me run it now, and you will see that now it will display it 5 times, because initially the value of b is 5. It will see that the value of b is less than 10, increment it once, display running, and then it will repeat itself unless and until the value of b is less than this 10. Okay, so let me run this section, and you will see here that, okay, you will see here that it is now running, and it is running now 5 times. Okay. So this is one of the example of loops. Similarly, in all of this course here, there is another very important command, and that is the help command. So suppose if you want to know about some functions, or you want to get the help regarding some functions, you will, what you can write here, you can write here help, and after it you can write the command here about which you want to get help. So help while, like while is the keyword here in this MATLAB. So pressing enter here, you will see that all the stuff related to the while will appear here, and despite it, you can also click here this doc here, and it will also show you all the details of the while command here. Okay, so you can also check tips here, and everything whatsoever you want to learn about it. Okay, so help is also a very immediate and very important function inside the MATLAB package, which is used inside of it, and it also works without any internet connection as well. Okay, hello guys. So today's lecture is also very important, which shows us the capability of MATLAB to read different files and audio files, images, and today we will see how to carry out this task. So let us start it, and first let us see how can we read the text files which are already available in the MATLAB path. Okay, so let us have this text file. This is abc.txt, which is already available in the MATLAB path, and we want to read it. So in order to read it and store it in another variable, let us call that variable as a, and in order to read it, there is a command here, and that is text read. Okay, so in order to read text, what will happen, we have to write the name of the text file inside these inverted commas and write the extension with it as well. Okay, so if you don't want to show all the bits here or this command window, what you have to do, you have to put this semicolon here, and after pressing enter, you will see that a variable a has been created here in the workspace, in which all the variables or all the values are the same, which are basically in the abc.txt file. So let me double click over it, and all the values here in this abc.txt are the same, which are now stored inside a. So let me show them here, and these are the values here. So you can basically process them and carry out all the processing steps, whatever you want it to do. Okay, so this is all about the text files, which can also have the data which you will have. Okay, so let us go beyond it, and let me clear it again. So after it, another very important thing which every data scientist and every person who is associated with the financial data sets and many other things, he has to work in the Excel files. So here in the MATLAB, there is also a command which is used to read the Excel files as well. Okay, so let us have a variable b in which we are aiming to store the values which are already available in the xxl file. Okay, so let me double click over it. Okay, so double clicking over it, I can see here that it has basically two sheets. In the second sheet I have these values, only the numerical values are available in the second sheet, but in the first sheet what are the values here? So the first is the name and then the scores. Abbott has 2 marks, Andrew has 4 marks, Bishop 7, Charles 3 and Martin 6. Okay, so this is basically the Excel file. Let me also go towards this file as well. So let me go to the documents and here MATLAB. This is the file I want to read. Okay, so this is sheet 2, this is sheet 1, and sheet 1 is basically composed of all these values, which also consist of these strings and these numerical values as well. Okay, so what will be the strategies and how can I read it inside the MATLAB? There is a command here that is called the xlsx. Okay, so in order to read it, what I have to do, again I have to write the name of the file. So xxl.xlsx. Okay, so that is the name with the extension here. So let me press enter here, and when I will press enter here, what will happen? Another variable b will be created which will store all the values related to this sheet. Okay, so let me have a look at the values which are stored in b. So these are the numerical values which are already available in the first sheet of my Excel. But have you noticed that the first sheet also had some string values as well, but it is not showing us any string value. Similarly, what if you want to look at the values which are available in the second sheet of my Excel file? So in order to do it, what you have to do, you have to press comma here and write 2 here. So writing 2 here will give us all the values which are stored in the Excel file. So now calling it double b here and pressing enter. Okay, so let me have a look at this bb value, and these are all the values which are already available in the second sheet of my Excel file. Okay, but in order to have a look at all the values of the sheet 1, what I have to do, let me have here some other variables here. So writing them x comma y. Okay, and these square brackets equal to xls read. Okay, and then xxl dot xlsx, this one, and as I want to read the first sheet, if I am not writing 1 here, so by default MATLAB will also take the first sheet and will read it as well. Okay, so after doing it, what will happen? So one of these variables will store the numeric values while the other one will store all the string characters. Okay, so the first one here will store the numerical values while the y will store all the string values which are available here. So doing it right now. Okay, pressing enter. So that's it. Here you can see that x has now stored all the values which are numeric, while y has stored all the values which were not numeric values but all the string values or the characters. Okay, so in this way you can basically read the Excel files which are consist of all the numeric and non-numeric values. Okay, so now again CLS. Also many people have to use the CSV files, which are basically the comma separated files. In order to read the comma separated files, MATLAB also have the CSV read command here as well. Okay, and you can also take a look over it by writing help here. Okay, so that is the documentation of the CSV read command, and here you can see that just by writing the CSV read and file name you can read it as well. There are also CSV write, just like it you will also have the XLS write here, as well. So what does xlswrite do? It basically write all the values which are stored in some variable into the Excel file. Okay, so these are the things which we will discuss later on. So after reading all the text files, we can also have some audio files as well. So here we have this audio file which is called music.wave. In order to read it, there is a command here, and that is basically the audio read command. So audio read is also one of the important command here in the MATLAB. So reading it, what we have to do, we have to write the name of my file and then with the extension here as well. Okay, so just by reading it and storing it in a single variable, just let me call it m, will just give me all the samples which are available. But if you will write here m and f, and so writing m and f here, what will happen here, m will store all the samples here, while f, what will this f do? F basically stores the sampling rate of this music as well. Okay, so let me run it and I will see here that let me check the length of m. So it has basically 2,42,551 samples, while the sampling frequency is 44,000 hertz. Okay, so in order to play it again, what we can do here, there is a command here, and that is called the sound command. So sound command not only take the samples here, but also the frequency with which you want it to be played. So let us play it with the sound command. So you will hear it. Okay, so that is basically the music file, and reading and then again playing the music file is also one of the feature which MATLAB package gives you. Okay, so this is all about the audio files, and in order to process all the values of this audio, you can also use this m variable, which also consists of all these sampled values of the music file. Okay, so this is about the music file. Similarly, we can also have some images as well, which can be in the JPG format, PNG format, and so on. So in order to read it, what we can do here, also there is another command, and that is the imread command. So you can very easily see that how many commands did we use here. So the first command was the text read, second one was the xlsx read, third one was the csv read. Okay, you can see that whatever you want to read, there is the name of that media, and after it you have to write the read. Okay, so in order to remember it, you can also use these things as well. So audio read, and then now im read, image read. Okay, so this is the sequence you can use in remembering all the stuff which is related to the MATLAB package. So now let me read this image here, which is the JPG image, and writing it like img equal to imread, and now again using the name with the extension. If it was PNG, I would have written it here, the .png. Okay, so now writing it here. So if I want to take a look over it, what will happen? This is basically the colored image, and therefore it is basically the three-dimensional image. So in order to take a look over it, what I can do here, I have another command here, that is the imshow. So giving it this img, what will happen? It will show me this image here as well. Okay, so this is the result of the imshow command. So by using all this stuff here, what you can do, you can zoom it. Okay, you can zoom here as well. You can also use some other commands, just like saving it with some more extension. Okay, so if you want to save it with .fig format, in .fig format, and similarly .eps, .pdf, .png, so you can also change it and convert it into another formats as well, just like EPS, which is the vectorized format, and very useful for the people who want to see the very crispier images which are not pixelated when zoomed a lot. Okay, so these types of images are usually used in the LaTeX files. Okay, so in this I have shown you how to take a look and store and then again show different images in the MATLAB as well. Okay, similarly there is also another command here which is related to the videos. So if you have some videos, so you can also use video reader here as well, but it is somehow very advanced command, and I will get back to it after some lecture. So till then, practice or all the stuffs which we have covered in this video. So today we are going to discuss another very important topic in computer programming and MATLAB, and that is the function. Okay, so in computer programming you have seen the functionality of using different functions. It basically reduces the effort of writing the code again and again, and therefore there are basically two types of functions. The first one are the built-in functions and the second one are the user-defined functions. So in MATLAB we have different built-in functions, like if we have a vector here 1, 3, 6, and if you want to add the entities here, what you can do, you can write a function which is called sum, and it will give you the summation of all of it. Okay, similarly CLC is a function, clear is a function, and all of these are basically the built-in functions which are already available in the MATLAB. But if a user want another function which it want to customize to its own needs, so MATLAB basically gives you the flexibility of using such kind of functions. And in order to define these kinds of functions, what we have to do, let us go to the new script file. So in order to define a function here, what we have to do, we have to write a keyword here, and that is the function. Okay, after writing it, what are the steps here? So let me first write here equal, and here I have to write the name of a function. I am skipping some arguments here, and I will get back to it after a while. So writing, let me have a function which will calculate the sum and average of the numbers whenever I will call this function. So let me call it sm. Okay, so let me call it sm and giving it the argument x. So x can be a single number, x can be a vector as well. So giving it sm, and after it, when it will calculate something, it will also return me something, and that something will be written here. Let me call it smm, that is the sum, and avg is the average. Why I am not writing the sum here? Because sum is already the keyword, assigned keyword in the MATLAB. Okay, so you are requested not to use those kind of the words or the keywords which are already available in the MATLAB. So whenever I will get this sum, what will happen? This sum will calculate smm, and this smm will be the sum of x. Okay, and also the average is equal to sum divided by the length of x. Okay, you can also write any other statement here, but that is what this will calculate, and completing it with the AND statement, it will be like this one. So this is a function which will provide us these two types in the return when x will be provided to it, and the name of it will be sm. Okay, after it, what we can also write here, we can also write here the comments, and what are basically the benefits of using the comments. So let me write here, this function provides sum and average of the numbers provided to it. Okay, so writing it, let me save it now, and I have to save it with the same name with which I have given it a name. Okay, so sm is written here, so let me again write here sm and saving it in the same path. Let me save it now, so it is saved now. Okay, so now after saving it, I can assign, or I can call any number here. Let me use the same number here, and that is A136. Now in order to calculate the summation and average of it, what we can write here, let me write here x and y. These are the two numbers which a function will return us, and sm, the name of a function, and giving it a, it will give me the summation and also the average. Okay, you can very easily find that the summation of these numbers is 10 and the average of these numbers is 3.33. Similarly, whatever you want to do, it will do it for you. This is the summation, and similarly, what are basically the benefits? If you remember, we have basically written here some statements here which in the form of the comments. So what are the benefits of it? So let me write here help command, which is very important command in the MATLAB for getting the offline help, and writing here the name of the function, and what it will give me, you will see that the statement you have given it to it, it will appear as a help. So whatever function you would like to write, if you will write these type of statements in the form of the comments, it will give the user help if you will ask for it. Okay, so that is about the function statement. Similarly, if you want to amend in it, what you can also do, let me write here the function bar, and in bar I can also write sm and avg. So, okay, so that is, now if I will run this function, now you can see that it is also giving me this bar as well. There are some important things which we have to do with it as well, but till now I am leaving it as it. Okay, so sum and bar, just getting sum here, saving it, and now you will see that this is basically the bar which is from 0 to 1, and you can also change its characteristics from the same characteristic bar. Okay, you can change all whatever you want from here. You can write it as a line, as in stairs, stem, and so this is the stem function. Okay, so if you want to change them here, let me change it like stem. Okay, and then hold on, and then stem avg, saving it. These are all the commands which we have previously gone through, but in order to explain the fundamental characteristics of the user defined functions, I am again using them. So you will see that these are the two type of functions which are providing us these values, and these are here. Okay, so these are over each other. Why these are over each other is the first plot, which is from 0 to 10, is also written here, while the other one, which is from 0 to 3.33, is also over it. So these are basically overlying over each other. Hello students, so today we are going to discuss the line plotting in MATLAB. So we are going to see that how different mathematical functions can be plotted inside the MATLAB. Okay, so in order to do it, let us first go inside the script here, and here let me first write the CLC and then clear all. Okay, so after it, what we have to do in order to plot anything, what we should have, we have some values in the x-axis, and the x-axis we can call it as the independent variable. Okay, so writing x here, so let me write x here, and let me start it from 0, and I will end it at 1. Okay, so by writing it like this one, what I am going to do is that I'm starting the x variable from 0 to 1 with the difference between both of these digits as 1. Okay, so in order to reduce the distance here, what I can do here, I can write another column here, and between them I can write here any number with which we want these two to be apart. Okay, so any two digits here will be apart with the digit or with the number here which I am going to write here. So let me write it as 0.01. okay, so now this is x variable. Okay, so now in order to plot any other variable, let me plot here first. So let me have here the y equal to 0.5. okay, so that is y equal to 0.5, and what I have to do, I am going to plot it here from 0 to 1 with the distance between each digit here as the 0.01. okay, so after it, what I am going to do, I am going to write here plot. okay, so plotting it, what I will write here first, I will write the x variable and then the y variable. So after it, let me save it. okay, and let me save it with the plt name. So saving it and now running it, what I can see here, we can see that the line here is at 0.5, which is very thin here, and we can increase the thickness here as well. How can we increase the thickness? First of all, let me change its color. So in order to change its color, what I can do here, I can write these inverted commas, and in between them I can write R or C or B. okay, so B is for blue, R is for red, C is for cyan, and similarly K is for black. okay, so let me write here R and then printing it again. I can see here easily that the line here is now red colored. okay, similarly, in order to increase the width of this line, what I can do here, I can write this inverted commas and line width, and increasing the width up to 4 here. Let me see it now. okay, this, or let me increase it by 6. okay, so we can see that the width has been increased with this one. Similarly, in order to plot any other variable here, let me plot here the exponential. So exponential is exp, and writing it like this one, and writing it with minus x. What I can do here, let me print it, and I can very easily see that this is the exponential decay with the initial value of 1. Why is it 1? Because it is the multiplicative factor here, or the coefficient of exponential term here is 1. okay, in order to reduce the width of this line, what I can do, I can reduce it here, and here after it, what I will see it like this one. okay, so in order to print here some grids as well. okay, so writing grid here, what will happen, we will see that the grids will appear here as well. Similarly, in order to write the title of this plot, similarly x label, y label, what I can do here, I can very easily come over here and can write here, first of all, let me write the title. So in title, I can write here in between the inverted commas as the plot, or let me call it line plot. okay, similarly x label is the term which I want to be appeared on the x-axis. So on the x-axis I have, let me call it the time. okay, and over the y, what I have the amplitude. okay, so now let me print it, and I will very easily see that here the title is line plot. Over the y-axis I have this amplitude, while the time variable has been shown here on the x-axis. okay, so this is one of the very important properties of the plotting here. okay, similarly, what I can do here, that I have some more mathematical functions like the trigonometric functions, and those are sine and cosine signals as well. So let me write here the sine function which have the frequency of, let me call it 10 hertz. okay, so if the frequency of it is 10 hertz, so let me write the sine, and inside the arguments here, what I will have, sine of 2 into pi into f into x. Okay, so that is the value of sine here. Now let me print it here. What I will see that these are the values of the sinusoidal function, which I can see here very well. Okay, in order to increase the resolution of my plot here, what I can do here, I can increase the distance between each and every point here, and by reducing the distance, this is the reduction. So by reducing the distance between the points, what will happen, the number of points will increase, which will ultimately result in the increase of the resolution of my plot here. So if when the resolution is higher, I will see that the plot here will be crispier as that of the previous one. Okay, so similarly, if I will decrease it like this one, you will see that the plot will be like this one. It is not a very good plot. Similarly, if I will increase it like this, if I will increase the number of points by reducing the distance between the points here, it will be like this one, and similarly it can also be increased as well. Okay, so this is all about the sinusoidal waveform. Similarly, what if I have another waveform here, and that is y2, and writing y2 as cos, and cos of 2 into pi into f into x. Okay, and what if I want to plot them here as well? So when I will plot them here as well, what I will do, I will let me write here plot. Okay, that is x and that is y1. So now let me plot it. Okay, sorry, that is y2 here. Now let me plot them here, and I will see that only the cosine plot will appear here. Why is it? Okay, you will see that only the cosine plot is available here, but not the other one, which is this initial plot. Why is this? Because now the only one window will be replaced by the last one. So if I want to plot them both, what I can do here, I can write here figure for the first one. Okay, and similarly figure for the second one as well, and when I will plot them, I will see that both of them are now plotted separately. This is for the sinusoidal, while this one is for the cosine plot. Let me differentiate them by using different colors here. For the cosine I am for the sine I am using red color, and for the cosine I am using the cyan here. So you will see that both the plots are here. Now you can see that the title at x label, y label is only with the last plot here. Why is it? Because these commands are basically connected with the last plot here. Okay, so what if I want to plot them on the single plot? What I can do here? So in order to plot both the curves over a single window, what I can do here, that after writing the plot command for the first figure, I can write here hold on, and after it writing another command here, this will plot both of them on the single window here. Okay, similarly, now let me change the color here. Let me make it black, so the difference will be now clear. Similarly, now let me increase the width. Okay, line width is, let's say, again 2 and similarly printing it, I will see that now both are printed here. Similarly, let me increase the number of points here, and I will see here that the plots are now crispier, but you can very easily see that both are plotted here. Okay, similarly, if I will reduce the frequency here, and now let me print it again, I will see that both the plots are available here. So the red one is the sine one, the blue one is the cos one. So it is very difficult for me to see or to differentiate between both the curves here. So in order to differentiate them, what I can write here, I can write another thing here, and that is the legend. Okay, so in legend, what I can do for the first and for the second, I have to write two things here, and for the first I have sine of x, or write sine, and for the other one let me write cosine, and when I will print them, what will happen? Now you can see that the legend is now available here. Okay, you can also move it with the cursor here as well. Okay, so that is all about the plots here. Similarly, if I don't want to write these plots separately, what I can do here, I can only cut it from here and also write it here as well. Okay, so writing it here as well will serve the same purpose. What is the issue? Okay, so it is basically not allowing me to write both the line widths and colors in both the line widths in the same plot. So let me change it now. Now let me change it. Okay, you will see here that just writing only one line width here, it will serve the purpose, while the color of both the plots are now separated from each other. Okay, so that is all about the line plot here. Similarly, what if I want to plot them separately over the separate plots in a single window? So what I have to do here, the concept of subplot is introduced here as well. Okay, so in order to plot them in a single column double row figure, what I can do here, I can write here subplot, and in subplot what I can do, let me have 2 rows 1 column, and this is my plot here, and in the case of this 2 rows 1 column, this is my first plot. Similarly here, let me remove this, hold on, and here subplot 2 rows 1 column, and this is my second plot. Okay, so let me run it now, and you will see that in this 1 column and 2 rows I can see that the first one here is the sinusoidal waveform, while the second one here is the which one, cosine. Why is it showing this one? Because I am using legend with the second one only. So let me remove it, and similarly using these two with the upper one as well, and now printing it, what I will get, I will get this grid lines with both the plots. Similarly, the title, X label, Y label with both the plots. Similarly, what if I want to plot them in a single row double column? What I will do, I will just change here the, I will just write here 1 row 2 columns. Okay, similarly here 1 row 2 columns. So this is the first 1 row 2 column overall plot, while this one is the first plot, while in the 1 row 2 column plot, this is the second one. So let me printed them now, and I will see that the printing is now done like this one. Okay, so that is all about the prints now. So today we have seen that how to print different functions inside the MATLAB and how to compare them visually on the basis of different plots. Okay, hello students. So in MATLAB we also have another option which is related to the 3D plotting of any waveform of any mathematical function. So let us talk about it, and for it I am again going to the script file here and again writing clc and clear all. Okay, so now again let me write t equal to from 0 and 0.01 and here 1 as well. Okay, similarly the first waveform here I have is the x equal to sine of 2 into pi into f into t. Okay, so that is the sinusoidal wave, and the frequency I have here is, again let me have it 1 Hertz as well for the simplicity, and another waveform here is let me have the cos waveform, and that is here 2 into pi into f into t. Okay, so that these are basically the 2 waveforms, and I can plot them separately as I have mentioned in my previous videos. So for plotting or seeing the 3D plot of this waveform, what I can do here, there is a command here, that is the plot 3. Okay, so in plot 3, what I can do here, first of all, I have to write the first waveform or the mathematical function here, similarly the second method here, and at the end I have to write the time instance up to which I have to plot them. Okay, so it will plot this one for the first time instant and the other one for the second time instance in such a way that those two time instances will be connecting in such a way that t will have the replica in the form of x and y coordinate. Okay, so let me plot it and you will see that how is it possible. So first let me save it. So plt3, giving it a name of plt3, and now you will see that this is the 3D plot in which I can very clearly see that the first one here is the first thing and then the second thing here. So in order to check it, what I can do, let me click over rotate 3D, and here I can see that this is the rotation in which at one instance I have one curve while at the other instance I have the second one. Okay, so here from this point you can see that the first wave is the sinusoidal wave. Similarly, on any other axis you will also get that this is now the cosine waveform. Okay, so that is about the plot 3. Similarly, if I will increase the instance here and also increasing the frequency here, what I can do here, I will see that this will be the spiral shape here, and let me also have the grids here. Okay, so now it is clear that it is like a grid shape, and rotating it in a 3D manner, you will see that. Okay, so now this is from 0 to 1, and also here you can see that 0 to 1 here, which is the thing which I have previously showed you. Okay, so you will have different instances here in these 4 coordinates which will be from 0 to 1. So here as well you can see that this is the spiral shape, and looking at different waveforms here, you will see here that this is the, which one is this one, this is the sinusoidal waveform. Okay, so this is basically the one waveform, while the other waveform can also be rotated, like you can rotate it from here as well. So this is the sinusoidal waveform, while the other one was the cosine waveform, and so on. Okay, so these are basically in 3 dimensions. You will see that both of these will construct a spiral shape waveform. Okay, so that is all about the 3D plotting here. Similarly, this is the spiral waveform. What if I want to draw the funnel type waveform here, or funnel type shape here? I have to multiply it with another term, which is the exponential decrease. So exponential of minus t here and multiplying here with the dot product. Okay, similarly this one here, you can play with it as you like. So now plotting it here, and you will see that this is like a funnel here which is decreasing here. Okay, in order to have more looks here, so you will see that as the dimensions have been increased, here it is from 0 to 2, so it is now the more points have been added into it, because now 2 minus 0 divided by 0.001 will be the double of as that of the previously used points. Similarly, if I increase it more, you will see here as well. Okay, so this is all about it. Similarly, what if I made it like this one? You can play with it. This is another waveform in which the sinusoidal waveform has been decreasing exponentially, while the cosine waveform has been increasing exponentially. So you can see that this is another type of waveform which has different shapes in many dimensions. Okay, you can look at these shapes, and you will also have the concept from looking these mathematical functions that many of the 3D objects can be create it from these waveforms as well. Okay, so play with it. It is your task that you have to play with all these shapes, use more functions here like tangent hyperbolic, sine hyperbolic, and so on, and play with plot 3 as well. So after it we have another command which is called the surf and mesh grid. So I will also discuss those commands with the passage of time. So up till now we have discussed all about the plotting. Hello students, I hope all of you will be fine. So today we are going to discuss some more plotting options which are built in and already available in the MATLAB package. So let us first go into the script file here, and let me write here CLC first, which is a very good practice to include all these two options or commands here. So here first of all let me write here t equal to from 0 and having a distance between each point as 0.001 and here 1. Okay, so how many points will I have here? So actually if you want to calculate the number of points here, so first of all you have to write here, let me go to this, the initial point here is the 0, the last one is the 1, and the distance between each point here is 0.001. okay, so in order to find the number of points here, so what we have to do, first of all we have to write the last number, and from it I have to subtract the initial number, and writing the brackets here, and overall divided over the distance between each of the point which I have taken here. And here as you can see that in the M file, this is the first point and this is the last point. So 1 minus 0 divided by 0.001. So from it I will get the total number of points which I have, and I have here 1000 points. Okay, similarly instead of this I can also use another command which is built into the MATLAB, and that is linspace. Okay, so in linspace what I can write here, I can write here the initial number, the last number, and instead of writing the distance between each of the point here, I can write here the total number of points. So writing 1000 here will also serve the purpose which have been done by the command which I have used here with the colon here. Okay, so these are basically the two commands. Linspace is also one of the command, and I can also use here instead of this one. Okay, so now I am using this one. After it what I have to do, let me write here again the sine wave. Okay, and the frequency of this sine wave is, let me have it 1 hertz and 2 into pi into f into t. Okay, so this is the sine wave, and in order to plot it what I can do here, I can write t and I can write y here, and then I have to save it, and PLTTING, let me call it plotting, and save it. And now you can see that this is the plot which I have to see. Okay, I haven't added any title here, I haven't added the grids here, x label and y label as well. Okay, so this is the plot here. In order to see the separate points here, as we can see here that in order to, when I will reduce the points here, what will happen, the plot will not be clear here. Okay, just writing it here, I'll see that the plot is not very clear here because now it has taken a very less number of points, because now the number of points here are 10. Okay, why 10? Because 1 minus 0 divided by 0.1 is 10. So the first point will be here, second here, third, fourth, fifth, 6, 7, 8, 9th and 10. Okay, so the resolution is not quite higher. Why the resolution is not quite higher? Because the MATLAB package and all the available packages and softwares in the computer, we have all the digital packages. All the things they do is basically based on the digits, and after it what you have to do, they basically connect points which are available here. Okay, so in order to check the points here, what I can do here, I can also write here this, and let me write O here as well. Okay, so now let me Okay, now you can very clearly see that these are the points. This is first, second, these are basically 10 points which are connected by this line. Okay, so if the number of points are here less, so the resolution is less, and we have very small resolution, and the curve here is not so crispy. So in order to increase it, increase the number of points here, what I can do here, I can increase the number of zeros here, and you will see that the points are now increased and the plot here is now crispier. Okay, this is one of the method, and similarly removing it from here, we can also see all the points here and also this one as it is. Okay, so these are all the points which we can see here as well. So this is basically not a very good way of looking at the digital signal. So in order to reduce it, what MATLAB offers us, there is another command here, and that is called the stem command. What does a stem command do? Let us now run it, and I will see that now this is a digital signal or discretized signal. Okay, we cannot call it the digital signal, but it is the discrete version of the sinusoidal wave, in which each sample has been separated from each other with the time of 0.1 instance. Okay, so this is, you can also call it the discretized sample. So in order to increase the discrete samples here, what I can do, I can decrease the distance between 2 points, and writing it here as well, you can see here that it has now decreased it. Similarly, if you want to decrease it some more, let me increase the distance here. So this is 0.9, and you will see that one point is here, the other one is here, and the resolution is not that much clear. Similarly, writing it 0.1, okay, it will be like this one. And also, if you want to use the same things which I have previously used, so writing K here for the black, and also the line width 4. Okay, so now running it, and I will see that it has been increased. Okay, and now this is the discretized signal. Now in order to use other options here as well, so writing grid here, and also the title, and the title is, let's say, signal sampling. Okay, so this is our signal. Okay, similarly, if you want to increase the frequency here, what will happen? Okay, so now with the increase of frequency, the number of points we have are lesser. So let me increase the distance between each point here, and I will see that now it is making some sense, because now the samples have been increasing, and this is all about the stem command here and the digital sampling, which is usually used in the signal processing. So we have started this series which is related to the MATLAB, and previously we have discussed different plotting schemes which are related to the 2D plotting, 3D plotting, and also we have seen that how to import different data sets which are currently available in different forms, like in TXT files, in Excel files, in the form of audio files, and video and images files as well. Okay, so apart from the plotting techniques which we have previously seen, today we are going to discuss a very easy, very flexible to use plotting function which is available in the MATLAB, and that is called the ezplot. Okay, so suppose you have to plot the sine wave. So what are the steps involved in the sine wave? First of all, you have to basically define the time variable, and you have to define the points that from where to where you have to define this time variable, and what will be the difference between each point in this time vector. Okay, so let us have this one. So here this 0 0 1, and after it we have to write this one, and after it we have to define this y equal to sine of t. Let me have it, and after it what we have to do, we have to plot it like this one. Okay, so it will give me like this one. Similarly, if you want to, if now let me increase this and plot it now. Okay, I have to run it again, and after it I have to plot it. So you will see that this waveform will appear. So this is basically very tedious task, in which what you have to do, you have to define two functions at the same time. So in order to tackle all these issues, all these things, there is another plot which is the ezplot. So what is the ezplot? Inside of this, sine of x, and it will plot this one. Okay, so this is the ezplot, and it is basically taking all the range from -2 pi to 2 pi and plotting my plot in this range. Okay, similarly, if you want to plot other variables here, in order to plot each and everything here, what you have to remember here is that you have to write those things inside these inverted commas. Okay, so initially you can see that when I have written this statement, it did not work because it did not know that what is x. So now when you will write this one, so ezplot will treat it like the symbolic representation, which we are going to discuss in our upcoming videos. So this is the sinusoidal waveform. Similarly, if you want to display tangent hyperbolic x, what it will do, it will give you this. If you want to use the grids, okay, similarly title is already defined, and all other things, these can also be plotted here. Similarly, if you want to increase or decrease this limit, what you can do here, you can write it after this here inside these square brackets. So let me define it in between -5 multiplied by pi up to 5 into pi. Okay, so you will see that the range is now increased, and it is from -15 to 15. So you may ask me that what if I want to do all the formatting which I usually do with all my formats? So in order to do it, I can click over it. This is the last one here, and that is the show plot tools and dog figure. Clicking over it, and you will see that this plot will appear. So if you want to format this one, click over it, and it will be shown like this dotted one. After it, what you have to do, you have to use this property editor, and in this property editor you can change the width of it. Okay, you can see that the width has changed. Similarly, if you want to increase the width some more, okay, so this is 4 now. Similarly, if you want to use other lines here, so this is the dotted one, similarly this one and this one as well. Okay, there are different options. In order to change the color here, you can change colors here as well. If you want to use marker here, so what is the marker? These curves or these plots will be represented with some markers. Okay, so let me use this marker here. So you will see that, let me decrease its width, and here we can see that all the markers are now here available. Okay, similarly we have many other options available here as well. So these are 6 and so on. You can also use here this white color here and so on. Okay, more options and more in using more properties here, we can also use this one. Similarly, in order to format this one, just you have to double click over it, and you will see that different options will appear here, and by using these options you can see that you can change all what you want to change here. Okay, so selecting it and now making it 3. Similarly, increasing the size here, size will be increased. Normal, you want to make it bold, it will be bolded, and so on. Okay, similarly, what if you want to insert y label here? What you have to do, you have to clicking over the y label, what will happen, this box will appear, and here let me call it amplitude. Okay, so this is the y label, and you can see that this is now label. Similarly, in order to change the label of x here, I can also use here the, let me call it time. So you will see that time is appearing here. Similarly, in order to change the range, you can also change it from here. Okay, scale is linear, you can also use the log scale as well. Okay, and you will see that the plot will be changed here. Okay, after it, what you can do here, you can also save it, and also save it as other formats as well. Okay, so this is about the formatting of the plots which we can get from the ezplot. Similarly, you can also let me remove it. So if you have some function here, let me have x square, so writing it here, x square plus x plus 1. Okay, so let us have this function, and what I have to do, I want to plot it, so just writing it here and pressing enter, it will be plotted like this one. Okay, so you can plot here everything whatever you want by using this ezplot. Similarly, you can analyze those things as well. If I want to increase the order of my equation, what will happen now? You can see that the curves will be like this one. Similarly, now making it this x cube and x 5 minus this one, now you will see that the shape of this plot will be like this one. Okay, this is all about the ezplot, and you have seen the uses of ezplot. Thank you so much, and I will see you with some more problems and with some more solutions in our upcoming video. Thank you so much. Welcome back, students. So in this video we will see how MATLAB can be used to solve the linear equations of any system by using the matrices. Okay, so let us have a system of equations composed of two equations. The first equation is 6x plus 2y equal to 7, while the second one is 3x plus 7y equal to 10. We have seen last time that a system of only one variable can be very easily solved by using the MATLAB here. So suppose if I have the equations which are of two variables, and in order to solve them, what I have to do, first I have to convert this system of equation into matrices. So converting them into matrices, what I will get 6, 2, 3, 7, and in the form of the matrices here. So that is the matrix of size 2 by 2. Similarly, x and y will be in the column matrix, and at the right side of it I will have 7 and 10 as the column matrix as well. So what I have to do, I have to solve them, and in order to solve them, the fat matrix or the 2 by 2 matrix will be called the matrix A, while the x, y variables will be stored into the matrix or the vector x, while 7, 10 is the vector of the size 2 cross 1. 2 are the rows here, while 1 is the column here. Okay, so in order to find the x, what I have to do, I have to use this equation, which is now this one, x equal to y multiplied by inverse of a. Okay, so in order to do it, let me go towards the MATLAB and let me solve it, which is now 6, 2, 3, 7. Okay, so now let me go to the MATLAB here. So again I have the matrix 6, 2, and the other entity here 6, 2, 3, 7. 3, 7. So that is the matrix. And similarly, what is y composed of? So y is basically 7, 4, I think 7, 10. So y is basically the column matrix, and that is 7, 10. Okay, so it is now this one. So in order to find the value of x, what I have to do, I have to find the inverse of a, and then I will multiply it with y. So writing it, I will get these values, and that is the solution of my system of linear equations. So that two equations are now solved, where the value of x is this 1.80, while the value of y is this one. Okay, so in this manner we can solve any system of equations by using the MATLAB, and that is a very handy and useful application of the MATLAB. Similarly, what if we have more than two equations with us? So suppose here we have this system of equations in which we have three variables now, x, y, z, while the system here consists of three equations. So now in order to solve it, let me first convert them into the matrices. So the first fat matrix is this one here. This is the first fat matrix, while this one is the column matrix of all the required variables, while this one at the right hand side is are the terms which are available in my equation. So I have first of all, okay, so I have first of all write them like in the similar manner. So writing them here again, that is now 5 minus 8, 9, 5 minus 8, 9 in the first row. Similarly, in the second row, what I have 2, 7 minus 8, 2, 7 minus 8. In third row, I have 10, 2, 2. 10, 2, 2. So that is my matrix A. Now in matrix or the column matrix Y, how many values I have? I have three values. And what are those values? Those are minus 10, 9, 7. Minus 10, 9, and then 7. Okay. Sorry. As this one is basically the column matrix, so I have to put this semicolon here. So that is like this one. So in order to find the value of x, again here what I will do, I will first find the inverse of A, and then I will multiply it with y, and I will get the answer. And these are basically the three values which are the values of x, y, and z. And after putting those values in the equations which I had earlier on, I will see that these values will satisfy those equations. So by using this similar method, you will solve any system of equations which will contain any number of variables, whatever. So another very important video which is related to the MATLAB, and today we are going to discuss the symbolic expressions. So what are the benefits of using the symbolic expressions? So in previous video we have seen that in order to solve different equation we have to write their coefficients. Okay, so with the help of the symbolic expressions we may write the variables in their original form, and then we can process them as we want them. Okay, so in order to represent the symbolic expressions, what we have to do initially, we have to use the command which is this sims command. Okay, and after it we have to write the symbols whatever we want to use. Okay, so let me use x here because x will be the only variable which I am going to use in my equation. So writing it and then pressing enter, what I will have sims x, which will be represented like a structure here. Okay, so you may see here, and it will be stored like a sim here. After it, what we can do, let me have it equal to a, and a is equal to x square plus 1. Okay, so let me write x square plus 1. So in order to write the square, I have to use this cap operator and then 2, and then after it I have to write 1, and let me make it equal to 0. So in order to use the equality operator, what I have to do, I have to use these two equal signs, while one equality operator here will be used as the assignment operator. The same principle has been used in other programming languages, and most of you are well aware of this terminology which I have used. Okay, so after writing it, what will happen, let me press enter, and I will see that the equation will appear here, which will be like this one. Okay, so in order to make it very clear and very beautiful as that of our equations, we have to remove this cap from it. So in order to do it, I can also use another function here, and that is the pretty function, and giving it a, what will it do, let me press it and I will see that now this expression is here, which will have this x square here. Okay, in order to solve it, what we can use here, I have another very important function, that is solve. So just giving it a, it will give me the answer, which is now this one. Okay, so you will see that these are the two factors of this equation we have, which was basically x square plus 1. Okay, similarly, in order to write the previous equation which I had, so it was basically, let me write it equal to b, and b is x square plus 2x plus 1, and that is equal to 0. Okay, so that is the x square plus 2x plus 1, and in order to solve it, what I can use, I can reuse the command here solve, and giving it b, it will give me this solution. So this is the solution of my equation. Okay, so apart from solving equation, symbolic toolbox can also be used for other purposes as well. So let us have again sims x y, and here we have this c and m as well. Okay, so suppose we have these symbolic expressions, and in order to write the equation 1 equal to y, and that y is equal to the x square plus 2x plus 1. Okay, so suppose we have this equation, and here we can see that this is the equation in the ordinary form. So in order to write it into the form which is prettier than that of this, what we can write here is we have the command which is pretty, and writing equation 1, I can very easily see that it is now x square plus 2x plus 1, which is like the usual one. Okay, similarly, now in order to solve it, what we can do here, we can write the command solve, and giving it the equation 1, it will give me the roots which are given like this one. Okay, so these are the roots of this equation, and writing the value of y here will give me this value. Okay, similarly, let us have this equation, and if we want to solve it or write it in the feasible form, what we can do here, we can write here simplify, and in simplify equation 1, we can see that this is y square is y is equal to x plus 1 whole square. Okay, so that is the simplified version we will have. Similarly, suppose if we have another equation, and let us write it, let me first CLC. So we have equation 2, and this equation 2 is, let me have this x plus 1 divided by x square plus 5x. Okay, so this is basically the equation we have. Okay, so now this one is the equation, and writing it into the form of prettier one, so pretty equation 2, so it is like this one. Okay, similarly, in order to see that what are here the denominators and numerators here, so writing it like n and d equal to numden is the command here, and writing this equation 2, it will give me the numerator is x plus 1 and the denominator here is x square plus 5x. Okay, so this is another command here. Similarly, let us have the equation here, and writing sims e, m and c. Okay, so writing e equal to equation 3 is e equal to the m multiplied by c square, so e is equal to mc square, and in order to find the equation or solution of it in terms of m, or let us say I want to find out the solution for c here, what I can write here, I have to solve this equation, which is equation 3, and I have to solve it in terms of c, so it will give me the solution which is here. Okay, so you can very easily find the solution for any variables by using this one. Similarly, if you have to find out it in terms of m, what it will give you, here the answer will be is equal to e divided by c square, and writing this. Okay, so this is a divided by c square. Similarly, now if you have the equation like we have already defined x plus 1, and this is whole square, and writing it equation 6 equal to this one. Okay, so now okay, so there is an issue with it, and what was an issue here, I have written the wrong bracket, so this is not this one. And now in order to we can see that while expanding it, I will get x square plus 2x plus 1. So MATLAB can also do it, and expanding it equation 6, and it will give me x square plus 2x plus 1. Okay, so this is all about the symbolic expressions. You can use these symbolic expression for solving different number of equations for your own assignments or for your own task. It will be very useful toolbox for the mathematicians or all the people who have been working with the equations. So this is our final video of this MATLAB for the beginners series. And in this overall series, what we have covered all the basics which are related to the MATLAB. Okay, so if you are going to use the MATLAB for the numeric calculations in engineering, in other scientific fields, what you will need to do is basically covered in this video. Okay, so that is the overall scenario and overall functionality of the MATLAB, whatever we have covered in this series. Okay, apart from it, if you want to use MATLAB for other purposes, what you have here, you can see that this fx is written, and just by clicking over it, you will see that different options will appear here. Okay, so these are the language fundamentals, mathematics, graphics, and GUI building, and so on. These are all the functions which you may use inside the MATLAB, and these are called basically the toolboxes. Okay, so all the toolboxes are available here. You may see here that these are the toolboxes which you can use. So econometric toolbox, DSP system toolbox for the digital signal processing, filter design, HDL coder for the hardware descriptive language, and so on. So these are all the toolboxes which you can use. So let me have this image processing toolbox, and here you will see that other options will also appear, just like image export and image import, export, conversion, display and exploration, image enhancement, image analysis, GPU computing, and so on. So clicking over one of it, you will see more options, and basic commands will be seen here once any of these will be covered. So just stopping over it, and you will see that all the description about the commands will appear here, and you will see that the description, by using this description, you may use them anywhere, whatever you want. Okay, similarly, apart from it, you can also have different conversion tools as well here. So system test is also available, just like construct, test, test case, and signal authoring. Okay, so these are all the things which will be used for the advanced uses of the MATLAB. Okay, so these are all the fundamental functions which we have already used, just like CLC. Okay, so you will see that this MATLAB function clears all the input and output from the command window display, and so on. Okay, similarly other commands as well. So I am not going to dive into the details of these commands. So this is the conclusive video in which I am going to tell you that you have covered all the basics of the MATLAB, and this is the MATLAB for beginner course. And in our upcoming course, we are going to convert from the MATLAB into the Python, and some Python packages which are mostly related to the MATLAB and which have the same functionality as that of the MATLAB will be covered very soon. Okay, so in this course you have covered all the basics, and for further advanced courses stay tuned to our channel, and I will see you with some more courses. Thank you so much and take care of yourself.